What powers the technology behind your smartphone, computer, and even electric cars? Let's dive into the world of semiconductor materials. Semiconductors are materials with electrical conductivity between conductors and insulators. Firstly, let's explore intrinsic semiconductors, which are chemically pure and fundamental to understanding this field. Extrinsic semiconductors are doped with impurities to alter electrical properties, crucial for devices like transistors. Semiconductors are categorized into two types based on the charge carriers, N-type and P-type. Applications of semiconductors are vast, from microprocessors in computers to sensors in automotive systems. One challenge in semiconductor applications is miniaturization, pushing the limits of how small device components can be. Solutions include advanced materials and innovative manufacturing techniques to overcome these challenges. The impact of semiconductors on technology is profound, enabling the development of faster, smarter, and more efficient devices. Looking ahead, the future of semiconductors includes potential applications in quantum computing and space technology. Educational programs and research initiatives are crucial for advancing semiconductor technology. Collaborations between academia and industry foster innovation and practical solutions in semiconductor development. Regulatory and ethical considerations are also part of the semiconductor industry, ensuring responsible development. The role of semiconductors in renewable energy solutions highlights their importance in sustainable technology. As we've seen, semiconductors are not just components, they are enablers of the modern technological revolution.